Knock knock. Who's there? Yo. Yo who? Yo mama's so fat it took two buses and one train ride just to get to her good side. Ooh-wee. All right, let's do some science. What's up, guys? Today we're studying motion, graphs, and calculating speed. It's going to be a long one. Let's do it. All right, so the first thing that we're going to want to do is recall and remember back in class when we did this simulation called the Moving Man. This was a physics-based activity where we clicked on this gentleman and we would drag him forward, and a motion graph would show forward motion with a positive slope. Okay, rise over run. Remember that? You would also click the gentleman and drag him backwards, and when you did that, the slope went from positive to negative, and it went downwards. Okay. But what happens when you would leave him alone? Time continued on, but the distance wouldn't change. We call this stationary or at rest, and that is represented with a zero slope. In other words, it's a flat line when you're looking at a distance time graph, okay? So the first thing that we want to do before we actually start revealing these answers is let's go ahead and break this graph down. So the first rule that I want you guys to remember when looking at a motion graph on STAR is look at the title. Okay, that's the first thing. This one's pretty generic. It just says motion graph. We'll move on. Then you look at your y-axis, which in my opinion is the most important axis on these graphs, because this is going to let you know how to read the entire chart. If you see the word position or distance, that means it's a distance graph. They mean the same thing, okay? And you can also look at the units. The units are usually going to be just distance. In this case, it's meters. That's how we know that this is a distance time graph, okay? If you look at the x-axis, it's always going to measure time, and in this case, it's measuring time in seconds. Excuse me. Pretty easy. Okay, so the next thing we want to do is how do we read slopes and lines, different gradients here on the motion graph? Well, the first one we're going to look at is this guy right here. So I'm going to just ask you questions based like when we did this in class long time ago. Is the line constant? Is it straight or is it curved? Well, it's straight. Okay, so we can describe it as constant. Is the slope positive or negative for this red line? Well, it's positive. Okay, and if we look at the other straight lines, the light blue and the dark blue, this is in between those, so we would describe this as constant, forward, and average speed or average motion. Let's look at this blue one over here. How would you describe that one? Well, is it straight? Yes, it is. Is it positive? Yes, it is. So this guy's going to be going forward, right? And is it faster or slower than the red line? Well, sir, it's got a steeper slope. I'm going to have to imagine it's going to be faster, covering more distance in less time. Well, that's 100% correct. Constant, forward, and the fastest of the three straight lines. Now let's go to this darker blue over here, ask ourselves the same questions, and we get the same answers, relatively the same. Constant motion, it's also forward because it's a positive slope. However, this one is the slowest because it has the gentlest slope of the three straight lines. Okay, the next one we're going to look at is this black line right here. Well, if you look at that one, it's a zero slope, meaning that this gentleman is actually going to be staying put, and we can describe that as at rest or no change in motion. It's the same, okay? No distance was gained or lost. Next one we want to look at is this gray line here on the bottom. Let me get another color. So we're going to look at this gray line here. Now the gray line starts at 0 for our distance, and then it ends at 0. Had a positive slope for the first half. If you look at this right here, it has a positive, oops, sorry. If you look at this, it has a positive slope for the first half, and then it has a negative slope for the second half. What does that mean for us? That means it was going forward, and then the guy went backwards, and he went all the way back to 0. We call that in physics returning to start, because you returned to the original distance, which was 0. Okay? Now, if we look at this yellow line up here, okay, I'm going to put a little check mark. That's where we're at. If you look at that one, it's doing the same thing. It just doesn't go all the way back to start. So how would we describe that? It's constant because it's straight. It's still forward, and then it goes backwards. It just doesn't go all the way to 0. So we don't say it returns to start. And then our last one is this green one over here. You can kind of see it right there. That one is curved, so is it constant? Well, unfortunately, we can say no, it's not. This one is actually the fastest on the chart because it covers the most distance in the least amount of time, which would be 14 seconds, and then it goes all the way right here for distance. Okay, so we can describe that one as increasing speed, and it's not constant because it is not a straight line. Okay, hopefully that made sense. Hopefully you remember this. Now we're going to change our y-axis to a speed graph, and some of the rules change. So hopefully you are ready for that. Here we go. All right, so now let's go ahead and recalibrate our brains a little bit differently, because if you look at the y-axis, which we'll get to in just a second, it is different from the y-axis of the previous chart. So let's start off with our title, and our title is still motion graph. So it's pretty basic, okay? And now let's go ahead and look at our y-axis, speed, velocity, and now you have different units. It's not meters anymore. So on the STAR test, if you see the word speed on the y-axis and then your units, it's not going to be distance anymore. Now it's distance and time in one axis, in the y-axis. Or if you see the word velocity, it's the same thing as speed, it just has direction. Okay, so if you see any of those three things, speed, velocity, or miles per hour, you know that this is a speed graph. Speed as in S over dt, right? Speed is equal to distance over time. Okay? Now, if you want to look at the y-axis, it stays the same. It's still time. It's still seconds. Not that important. The most important thing is you look at your y. Now, all of these things mean a little bit different stuff. So let's try our best to remember and get through these. So this time we're going to start on the green line that you see curving up. Okay, so how would we describe that? Well, is it constant? We still say it's not constant, okay? So we're going to describe it as, we get to use the A word now because we're talking about speed, so we can say acceleration, okay? So it is increasing acceleration, and we get to say that because it's a speed graph, and it is not constant. So that is not too difficult. The next one we're going to look at is this blue line right here. Now, as we learned in the other one, that's the fastest or the steepest slope of the straight lines. So how would we describe it in a speed graph? Well, let's see. This would be our fastest, like I just said. It is constant, so that hasn't changed, but now we can say acceleration or speed. So it's constant speed, constant acceleration. It's the fastest of the group, okay? So now let's go over to the, I think it's the orange line right here, okay? So that one goes, this one is going to be going, well, it's going to be speeding up, okay? And then it's going to stop right here, and then it's going to be slowing down. Okay, it doesn't rest, but it speeds up. Let me see if I can get the laser pointer. This one might be the first confusing one for y'all. So it's speeding up here, okay, and then it slows down. Now, the best way I can help you understand this, you really have to look over here, okay? Check this out. So imagine this first section right here. It's going 16 miles an hour. From 0 to 16 miles an hour is what's happening right here in the orange line that I circled, okay? That means it's going from 0, and let's just say it's 16 is right here. So it's going faster. That's what that line is showing us. Well, what happens when it gets here and it goes back down like this? That means that you are going from here and you're going back down, okay? But you don't go all the way to 0 because 0 would be all the way to the very bottom. Does that make sense? Just remember when you're looking at a speed graph, remember a speedometer like the one I'm showing you right now, because that is going to help you make connections there, okay? So how would we describe that? Well, there's still going to be straight lines, so we can still say they're constant, right? But it's speeding up and then slowing down. So it's constant acceleration, which is the first part, and then it's constant slowing down, which is this part right here, okay? Let's go to the next one, which is going to be this red one. This one is a much simpler thing to understand. That one is going to be constant forward acceleration. And this is the average one, right? It's in between this light blue and the dark one, so we kind of get it. Okay, here's the big one. All right, I need everyone to focus because this is how the state will trick you. Look at the black line. In a distance time graph, that means that the moving man is not moving. He's stationary. But in a speed graph, okay, this is the speed graph. That means that we are staying at 8 miles per hour. So let's just pretend that this 80, take away the 0, right? That means that when you see that line, that black line, that means that it has gone to 80. Let's pretend it's 80 or 8 instead of 80. And it stays there. In other words, this whole line right here is at that same speed. That means that you are not speeding up or slowing down. We call this in physics or in driving, we call this cruise control. So that means you are not accelerating. You are staying right there at this 80 or this 8, right? You are not going any faster. You're not going any slower. Guys, this is the biggest way they trick you in between these two graphs. You have to understand what I just said. Okay, whenever it's flat, a 0 slope in a speed graph, it is cruise control. The vehicle is not speeding up and it's not slowing down. Okay, all right, moving on. I believe it's this dark blue. This one's pretty easy. So it's still constant, it's acceleration, and it's the slowest out of the straight lines. And then this last one right here, it goes from, it's not return to start, so it's 0, and then it gets all the way up to 8. So that means it goes from 0, let's just say, to 80, and then it goes all the way back down to 0. So then it goes all the way back down, the speedometer. Okay, think of your y-axis as the speedometer. So this one will be fast, then it goes back and stops. So maybe it stops at a red light, maybe it stops at a stop sign, whatever. Okay, but the only ones that they really test you guys on are the ones that I emphasize, which would be the cruise control, the flat line. Okay, so hopefully that is making sense, and you can rewatch that part of the video as many times as you need to if that was confusing, because ready or not, it will be here next week. Okay, all right, moving on. All right, so let's go ahead and try it with our star question example, see if you guys learned anything. So the graph shows the distance of an object traveled in 11 seconds. The very first thing I told you guys to do when you get one of these questions is look at the title. So you already know based on the title, this is a distance over time. Excuse me, this is a distance graph. That means you look at your y-axis. I already taught you how to break that down. This is showing just meters, not miles per hour, not meters per second. It's just showing meters. So this is an easy one. And you look at your x-axis and it's showing time. Pretty simple. Let's see what the question asks. Which answer choice best describes the movement of the object between the times of 0 to 6 seconds? So we're looking for a time interval. So we're looking at x from 0 to 6 on x, which is this section right here. Well, what does it do? Well, I just taught you that, okay? So is it a straight line? Yes, so that's constant, okay? Is it positive? Yes, so that's forward motion, okay? And yeah, I guess that's really all we need to know, right? Let's look at our choices. So F, it's moving at a constant speed. Well, if you paid attention, you should kind of get the answer to this one pretty easy, right? Let's look at G. It's accelerating. Well, we only said we can use acceleration when we're talking about a speed graph. So technically, you're not even supposed to be using that word. So that's wrong. H, moving towards the north. Okay, this has nothing with direction. We don't have a compass rose. We don't know if this guy's going east, west, whatever. We do know he's going forward, though, or whatever this is, it's going forward. So that's wrong. And then stopped would mean at rest, and that would be from 6 to 10 is when it rests. So that would be wrong. So the answer is F. Next question. Okay, next question. A student runs 2 times around a running path at a local park. Each lap is 3 kilometers. The student completes the first lap in 20 minutes. The student sits on the bench and rests, okay, for 5 minutes, remember that, before completing the second lap in 25 minutes. Which graph best represents the student motion? Okay, first thing I told you guys to do is look at the title. There is no title. Next thing I told you to do is look at the y-axis for all of these, and they're all going to be the same. It's distance and time. So we go by the rules of a distance time graph. In this case, though, it's kilometers. All we have to do is just match what the description in the little story is telling us, and then match it with the slopes, okay? The easiest thing to do here is look at the resting. So it says a student sits on the bench and rests for 5 minutes. So does this one show any resting occurring? No, that's all forward positive motion. Okay, so let's look at G. Does this one show any resting occurring? No, there's no zero slopes there, so that's wrong. So we've already eliminated two possible choices. Now we have to decipher between H and J, which is pretty easy. Let's go ahead and do that. So we're resting for how long? For 5 minutes, okay? So time would be showing a 5-minute rest. Okay, which one shows a 5-minute rest? 20 to 30, that's 10 minutes. This one shows halfway between 20 and 30. So without even having to mess with the positive slopes, just by learning our zero slope, our rest, our stationary, we can already get the right answer. But let's just go ahead and make sure that we know that it is H. So let's look at it. So the first lap is 20 minutes. That means that this first positive motion should end at 20, which it does, okay? And then the second one should be 25 minutes. That means that you're going to start from here and you should end up 25 later. So if this right here is 25 and you add another 25 to that, you should get 50, which is exactly where it stops. So H is our right answer. Good job. All right, so let's go ahead and try this next one. A car travels at a constant speed of 15 meters per second for 2 minutes. Okay, the car increases its speed from 15 to 25 meters per second during the next minute, and then travels at a constant speed again, for 25 meters per second for 2 more minutes. Okay, number one thing that I tend to do when we get these questions, check your title. If there's no title, next thing you're going to do is you check your y-axis. So the y-axis lets us know this is not a distance time graph anymore. Now it's a speed time graph. So that means the rules are a little bit different. And this is the one I told you they'll test you on. But here's the key right here. Constant speed, not constant acceleration, constant speed. That means on the little speedometer, wherever it says 15, that means you're going to keep going 15 meters per second for 2 minutes. That means the line should be horizontal. You're going to go at 15, if this is your graph, you're going to be at 15 for 2 minutes. So this would be like 1 minute and this would be 2 minutes. So the line should be across horizontally. You are staying in cruise control at 15. That's what constant speed means. You're not accelerating, it's constant speed, okay? So that means that this means your speed is decreasing, right? That means your speed is going down on the speedometer. So that's already wrong. This one is straight across, so that's good. We're looking for something like that. This one is straight across, that's good. And then this one shows that your speed is increasing. You'd be going faster on the speedometer. That's wrong. So we already narrowed it down between F and J. So the next thing it tells you to do is it says that the car increases its speed, okay, from 15 to 25. Well, let's look at F and J. Do you see an increase in speed here? Or would that number get lower if you're measuring it on the y-axis? Well, you're going down, so that means that the number would decrease. So speed is not going to get faster, it's going to get slower. And then if you look at this one, well, if you measured it on the y-axis, it's going up for that little section. So speed would be getting faster. The right answer, hopefully you understand, should be F. Okay? Because in the next thing that it tells you is constant speed, which is this section right here, constant again. Okay, good. All right, so I'm not crazy about this question, but I want to show you why learning the constant and at rest difference is so important. So let's go ahead and try this. So the speed of an object over time, so speed and time, is shown in the graph. The first thing we want to do, look at the title, speed versus time, and then the y-axis shows speed, and then the x-axis shows time. Okay, what did we just say? We said that a flat line in a speed time graph means that on a speedometer for this amount of time, which is like from right here to the 20, you are going 7, let's just say, what is it, meters per second? 7 meters per second there for that amount of time from those blue lines. And during that time, you're not speeding up or you're not slowing down. You're just staying at 7. Therefore, you are constant for that section. You're at constant speed. Okay? So let's not even look at any other time interval or line segment. Let's just stay with the 3 to 18. Okay? Let's just look at the 3 to 18 because that's really going to help us give us our answer. Then we'll look at the rest. So let's start with F, okay? So the object's speed is constant. Yes, that's what we just said that. We just learned that. Let's go to the next one. The H says the object is at rest. Okay, we know that in a distance time graph that would be true. That's not what we're studying here. We're studying a speed time graph. So we can already tell you that this one is wrong, okay? Let's look at G, all right? The object is at rest. We just said that. We can eliminate that one as well. It is not resting on a speed graph. And then the last one, J, says the object is at rest. Again, guys, I told you, learn the rules, and it's really simple. Let's see if the rest of this makes sense for F. So we know that the middle line segment is good. For 0 to 3, it says the object's speed is increasing. It is constant acceleration, meaning that it's getting faster. So I guess you could say the speed is increasing. So that is good. All right. And then this one says the object's speed is decreasing for this last line segment. Well, it's a negative slope. That means the number for your speed is going down. So the speed is decreasing. That's right. So the answer should be F. All right, I'm going to run through this one quick because I know it's getting kind of long. So we have time. We have speed. That means that these are speed time graphs. All you have to do on this one, you can read the question on your own if you want to, but all you have to do is just match up the time and the speed. So at 0.0 seconds, you should be at 2.6 speed. So time is our x and speed is our y. So let's go ahead and do this real fast. So at 0 seconds, you should be at 2.2. So time is right here for 0. This one is not at 2.2, it's at 0. So that's wrong. This one at 0, are you at 2.6 for your speed? Yes, you are. But does the speed ever change? Well, no. As you see here, the speed does change, but as you see here, it doesn't. It just stays the same. So you can already eliminate that one. And let's look at this one here. At 0 time, are you at 2.6? Okay, maybe. Are you at 0 here? Are you at 2.6? Yeah, okay. Well, let's look at another one. Let's just pick a random one, right? So let's go to, and you can do all of them, but we're just trying to save time here. So at 0.4 seconds, you should be at 1.8. So 0.4 here. Let's go up. Are you at 1.8? This one shows you're at 1.5. Let's check this one. 0.4. You go up. Are you at 1.8? Yes, you're in between 1.5 and 2.0. And that's how you're going to do this type of a question. All right. And you can go ahead and run through them all. I'm going to try to save you a little bit of time. Pause it if you want. Look at it. Let's move on to the last part. Okay, now it's time for the math part. So we're going to bring our friend the triangle back. And we know it's d over t. And we have our multiplication sign. And let's go ahead and get to it. All right, so we got the motion of a ball. We have distance. And we have time. So this is a distance time graph. What's the ball's average speed during the time represented in the graph? So we are going to have to use our trusty formula and our triangle, okay? So here's our triangle. You guys need to remember how to do this. You will not get your triangles on the STAR test. You guys have to do this on your own. You will get the formulas, but not the triangles, okay? All right, so what's the average speed during the time represented in the graph? So the easiest way to do this is look at the total time. So we start at 0 and we end at 50. So you have to take the beginning and the end and subtract them. That way you can get the whole total amount traveled. So, or time-wise, right? So 50 minus 0. Sir, where do we get those? Well, we got it from right here, the end and the beginning. So obviously 50 minus 0 is going to give us 50. So we'll write this on the side. Our time equals 50. Okay, so then what does our distance equal? Because that's the other component we need. Well, I'll use a different color. Uh, Distance starts at 0, and where does it end up? Well, it ends up at 10. So all you have to do is the same concept, 10 minus 0. So our distance ends up giving us d equals 10. All right, now I got to put them in the calculator like this, 10 distance over time. Okay, all you have to do is punch that in. So I'm going to go ahead and do that right now in my calculator. You guys can do it as well. And you should get an average speed for the whole time interval of 0.2 meters per second. Let's move on. All right, so we want to look at this distance time graph, and they want to know the average speed. So that means we're going to be using our formula for speed for the different time intervals. Okay, so you could do this a couple different ways. You can do it by each time interval and get the speed for each one. I guess that's probably the best way to do it. Let's just go ahead and start with that. So they want to know what is the average speed for 0 to 2. So that means we have to go from 0 to 2. So what is the time? Well, 2 minus 0, beginning and ending. So t equals 2. Okay? And then you start at, I'm going to use a different color here. You start at 0 for your distance, and at 2 seconds, because that's what it's saying here, when you get to 2, and the 0 to 2, where does it end up? Well, it ends up right here. So where is that on distance? 2. So again, you do the same thing, and so your distance 2 minus 0 gives you 2. So now if you put that in the calculator, distance over time, and you divide 2 over 2, you're going to get 1. So this one is already going to give us a correct answer so far. This is wrong, so C is wrong, and then B is wrong. So you can eliminate those two. Now the next one says 0.5, the next one says 0.75 on D. So one of those would be right, one of those is going to be wrong. So let's figure this out, all right? So here's where it gets a little confusing if you haven't been comfortable with this before. Now, if you want to pause the video and try to do this on your own, go ahead. If not, let me just show you how it goes, so that way you know how to do it when you practice, okay? So let's look at 2 to 4. So since the time we're looking at is from 2 to 4, you start at time 2 and end at 4. Hey, sir, but it's curved. That's kind of confusing. What do I do? Doesn't matter. Just follow the rules. You start at 2, you start at 4, or you end at 4. So where does that 2 go for distance? Oh, it's at 2. Where does it end up for distance? It ends at 3. So all you have to do is take, oops, sorry, I dropped my pen. All you have to do is take the beginning and ending time and subtract. So for time, it's 4 minus 2. Where did I get that? Right here and right here. Ending and beginning. So 4 minus 2 is 2. So your time is 2. And then let's go ahead, I'll use a different color. We started here, so your distance is 2. And then we were here, and your distance that ends is 3. So 3 minus 2. And that's going to give us our total distance. That's 1. That means you traveled 1 meter. So if you divide that, okay, what do you get? Well, a lot of you guys think that you know it just off the top of your head. You know, I would appreciate if you used a calculator, because that would eliminate any mistakes, especially for start. We can't afford to miss any simple ones. So you just put 1 divided by 2, and you get 0.5. This one says 0.75. So if you want to do the next one, it would be the same way. But in this case, we already know that A is the right answer. Hopefully that makes sense. All right, guys, last slide. Thank you for making it to the end. First thing we want to look at is what kind of graph is it? Is it a position time graph? Next thing we want to look at is what is the y measuring? Position. And if you remember from the first or second slide position also means distance. So we'll put a lowercase d, and then t represents time. So in this case, there's no answer choices at the bottom. I just wanted to see if you guys learned how to calculate average speed. So if I asked you, what is the average speed from time interval 0 to 2 seconds, how would you do that? Well, we would use our triangle, right? Which is just like this, okay? How would you do it? If you want to pause the video, go ahead and try it right now. Okay, welcome back. So let's go ahead and see how to do this. So if you want the average speed for time interval 0 to 2 seconds, you would subtract your 2 and your 0, and t would equal, actually let me do that smaller, t would equal 2 seconds, 0 minus 2. Okay, well at the 0 for time, what's the distance? I'm going to use another color. The distance is 2 at 0. Okay, and then right here, where does it distance end up at? Distance ends up at 3. So you would take 3 minus 2, because that's our distance. And what's the distance traveled in 2 seconds? Well, it's only going to be from here to here, which is 1. You subtract them, you get 1. So your distance equals 1. And if you divide that, put it in your calculators, use your tools, it's okay. So 1 divided by 2, and you get for 0 to 2, the average speed would be 0.5, and that would be meters per second because it's m and s. So meters per second. Okay, so let me ask you one now on your own, and you guys can try it. So what is the average speed, okay, from time interval, let's say 4 to 7, and let's assume that this is the middle between 5 and 6. Okay, so go ahead and pause it and give it a shot now. Okay, welcome back. Let's try this to see what you got. So distance equals time equals, let's see what we got. So the first thing we want to do is look at time. So time is at 4 seconds and it ends at 7 seconds. So what do we do with those, the beginning and the end, the 7 and the 4, we subtract them. 7 minus 4, what's the total time? That's going to give us 3. So t equals 3. All right, the next thing we want to do is we want to look at distance. So at 4 seconds, how far are we? We're 4 meters. Okay, at 7 seconds, how far are we? We're at 5.5 because it's in between 5 and 6. So how do we know how much distance we've traveled in those 3 seconds? Well, we have to take the starting and the ending and subtract them. So 5.5 minus 4. Put that in your calculator and you get 1.5. That's your distance. Now, how do you find the average speed from 4 to 7? Well, you just obey the triangle, and it's distance over time, so it's 1.5 divided by 3, and what you get is 0.5 meters per second. A little hint is if the slope is constant, like the way it is here, it's always going to be the same answer because the slope doesn't change. But now you know how to do it in case you have to look for a certain speed in a certain time interval, a certain section of the line. Okay, all right, guys, that was a really, really long one. I apologize. This was, it's supposed to be part of the mini-series, but I told you in the beginning this would have been a long one. Thank you for making it to the end. Hopefully this makes sense. You will see it on the week of STAR, guaranteed. So good luck. See you in the next one, guys.